So here's the very simple first fix that we have for the base and bound system. Again, you put the OS in the highest memory. So instead of putting it on top, you put it at the bottom actually, which basically means that nothing can grow into the operating system. Assume at compile time that the process starts at 0 with a maximum address, which is equal to the memory size minus the operating system size. So basically, the maximum address you can get is basically to fill the whole memory, right? So to start from 0 till 2000 in this case. Okay. Then load the process by allocating a contiguous segment of memory in which the process fits. So you already know that the code of the process is this much. So the code of the process is 500 kbs, and you need an extra 200 kbs for the stack and heap or something like that. And then sorry. So you allocate a contiguous segment of memory in which the process fits, and you basically start with the 00 address in the virtual address, starting at whichever address you start from. So here, for example, you allocate process C to start from 900. Okay, and this would be your base. Okay, and the largest physical address the process can access is the limit address. So basically, in this case, you could have had the whole area of memory for you, but since you didn't need that, so you basically just got 300 kbs. This is called dynamic. And then when you basically start, when you basically start running the process, the hardware adds the relocation register, which is base, to the virtual address to get a physical address. Okay, so you have the CPU issuing basically a fetch from a logical address. You have the base register, the relocation address that basically adds the logical address to the base register, and you basically check if it's greater than the limit register. You raise a trap that there is an addressing error. Otherwise, you basically access the physical address. So if the test fails, the processor takes an address trap and ignores the physical address. Now the processor has a couple of options. One of them is basically it knows. So if this is basically a read operation, right, then the processor cannot really do much about it. So the process is trying to access memory that it is not allowed to access. Versus if it's actually a write operation, if it's a store operation, then you might need to basically move the process to a larger chunk of memory. Okay, and this is dynamic relocation. So the advantages of this is that the operating system can easily move a process during execution, because you're basically going to, since you always have the virtual address, now you have had a trap. You have had basically you found that you're trying to store more data than what you already have, so you try to solve that by moving your data in the memory. And while this is actually it sounds very easy, because well, you are always accessing memory using the virtual address and you're just going to change one register. Okay, it still has its own disadvantages that we will talk about. You allow a process to grow over time, because you can change the base and the bound registers. You can implement fast hardware like the MMU that we were talking about to add and compare. This is actually a very, very simple logical circuit that you can actually do if you studied even the simplest course in logic programming and logic hardware. The disadvantages of this is that this slows down hardware due to the add on every memory reference. So every time you do a memory reference, you actually have to add something, which although done in hardware, it still takes time. You cannot share memory between processes, well, because you're bounded. So how do you, if two different processes are trying to talk to each other, the most efficient way would be actually to talk through a memory location. But you cannot do that right now, because a process cannot read anything except its memory. You're still limited by the physical memory size. Well, that's a no-brainer. Your degree of multiprogramming is very limited, since all the memory of all active processes must fit in memory, because right now we are talking about loading the whole process into memory, everything. And it complicates memory management. And of course, it becomes extremely slow when you start moving memory between different places. So this is what you need to implement dynamic relocation. These are the hardware requirements. You need privileged mode, just to prevent user mode processes from executing privileged operation, because you don't want it to try to change the base and bound registers, for example. You need the base and bound registers, and you need a pair of registers per CPU to support address translation and bound checks. You need the ability to translate virtual addresses and check if it is within boundary. This can be done with an MMU or with the actual processor that you have, but this will incur a larger overhead. You need privileged instructions to update base and bounds, basically increase them or set the values, new values for them. Okay, you need exception handlers to be able to process. Well, I just got a memory exception because I could not access this part of the memory, and you need the ability to raise exceptions actually.